in the book. I don't care. All right. So the empirical rule. First of all, the empirical rule works on what type of data? Who remembers? It works on a bell-shaped curve. So number one difference, the empirical rule works on a bell-shaped curve. Chebyshev's theorem works on any curve. Okay. Number two, the empirical rule works for one standard deviation, yes? If you remember that, we know the percentages. We have a percentage defined at one standard deviation. Chebyshev's theorem doesn't work for one standard deviation. Okay. Now, what else do we know? After 3 standard deviations, the empirical rule is undefined. After 3 standard deviations, the empirical rule is undefined. So if I were to say to you, what percent of the data is within 4 standard deviations, you would say, it's undefined. It doesn't tell me that. If I say, what is, after 5 standard deviations, what is it? It's undefined. It doesn't tell me that. It only gives me the answers for the first 3. 68, 95, 99.7. However, Chebyshev's theorem is defined after 3, right? Because you have a formula. Okay. What else is different between them? Fourth difference. The empirical rule gives you values. It gives values as the answer. Chebyshev's theorem does not. Chebyshev's theorem gives you a formula to work out. Okay. So the empirical rule just gives you the answers directly. Chebyshev's theorem gives you formula. Now, some of you are thinking to yourself, well, is there a formula for the empirical rule? Yes. You don't want to see it. For those of you that are going like this, no, I do want to see it. No, you really don't want to see it. Trust me on that. Okay? It's kind of like a hot dog. Just taste it, know it tastes good, and don't ask how they make it. You don't even want to know. Or the McDonald's chicken nugget. Just don't even go there. Sorry for McDonald's, but that ain't real chicken. Number 5. The empirical rule gives an approximate value. It gives an approximate value. The empirical rule gives an approximate value. Chebyshev's theorem gives you a low bound, a lowest bound, meaning it's at least this number. It might be more, but it's no less than this. So the empirical rule says, hey, it's approximately 68%, or it's approximately 95%. Chebyshev says, hey, it's no less than 75%, I promise. Okay? Now, how are they similar? That's how they're different. How are they similar? Okay, and the answer is they both try to tell what percent of data is within certain standard deviations of the mean. Okay. They both look to tell what percent of the data is within certain standard deviations of the mean. Okay. And just to clarify, the empirical rule says, just make sure you have it written down, 95% is within one standard deviation. Or excuse me, what the hell am I saying? That's all jacked up. I apologize. Post-concussion syndrome. There you go. 67%. 68%. 68% within one standard deviation. 95% is within two standard deviations. 99.7% is within three standard deviations. What's the formula for Chebyshev's theorem? Cheby. What's the formula for it? 1 minus 1 over k squared. Okay. Now remember that k has got to be greater than 1. So if I say what percent's within 1, the answer is undefined. It doesn't tell you that. If I say what's within 2, you just do the formula. 1 minus 1 over 2 squared, which is 75%. Okay. Say it again, please. Okay. K equals 3. You would do 1 minus 1 over 3 squared, which is 88.9%, approximately. Okay. All right, with that being said, there's the empirical rule in Chebyshev's theorem, the summarized version.